G'day chemists. So today we're going to look at calculation of enthalpy using Hess's law, only focusing on just the cycles. There's 2 points to this video. One, if you're really good at doing the equations but you need to bone up on your cycles, here for that. Or if that's the only way you need to learn it, this is that as well, right? You should be able to do most situations where you can do one, you can do the other. It's just that sometimes either the cycles or doing the equations are going to be just a little bit easier. This video is just looking at how to do it with the cycles. I have another video, which we'll put a link down the bottom, that'll show you how to do it with the calculations as well. So, your goal here is not to be the point where you're such a ninja at them that you can just do them for hours without really thinking about it. The goal is to get us to the point where we're ready to go and practice some on our own. So we'll go through some cycles and yeah, we'll be off good to go. Alrighty, so here we have a question. These are all IB questions. So 2-methyl-propan-1-ol can also be converted to produce diesel and jet fuel. The first step of the process is the production of 2-methylpropylene, and here we go, propanol to 2-methylpropylene, propene. It gives us water over here. Using the data below, calculate the enthalpy change, and you'll see that they've given us a bunch of equations. Here we have 4 carbons plus 5 hydrogens plus half an oxygen goes to whatever that is, doesn't matter. What's that? 2-methylpropan-1-ol, because it's up here. And here we have our what it's used to make the 2-methyl propene, and here we have the steam. Now what you'll notice is that each one of these is the elements, and each one of these is the elements in their natural state. So here we're technically using the enthalpies of formation, which means we could find these in a table, but they've been nice and they've given us the equations to go. So this is our target equation. Okay, we're looking for X kilojoules per mole of that one. So we write out our equation as we're going. This is our target equation. So I know it's already up there, but we're going to write it out so we can structure it out in the way that works for us. Then we're going to write down all of our products down here. So all our elements. So we need, this is going to be in the equation, this is going to be in the equation, this is going to be in the equation. Gold. Nice, not a problem. This is actually a pretty straightforward one. There's no multiplying of coefficients and stuff to come. So, as we get ready to do this cycle, let's have a look. We know that we're going enthalpies of formation. So, let's actually, we'll label these. So we've got a little blue star, green star, and a red star, or pink star, I suppose. Our first one, you take it straight from it. Minus 335 kilojoules per mole. See, all of the stuff in this equation is down here, and it goes up to that. When you're using enthalpies of formation, you actually don't need to balance it down here. You've just got to balance it up there. That's the important part. Our next one is minus 17 kilojoules per mole. Notice how it's changed direction though. Like this one's going up that way, and this one's going up that way. And the next one is going to be minus 242 kilojoules per mole. So, nice, fun. We've got our little cycle. And now here comes the hard part. Just jokes. It's pretty straightforward. What we do is this enthalpy is the same as all of these summed up. But look at the direction of that arrow. These two go in the direction of that arrow. Gold. This one goes against the direction of that arrow. So what we'll need to do is we're going to have to revert that, and we'll see that in a second. So due to Hess's law, X equals Y, or X equals the sum of Y's, because it's a stack in there. So it equals 335 plus minus 17 plus minus 242. But you notice again we flip the sign here, and that's because it's going against the flow of delta HY. And yeah, so we just add those together. Boom, done. That's it. 76 kilojoules per mole. That is the enthalpy of this reaction right here. Endothermic reaction, exothermic if it's negative, endothermic reaction, done. First cycle complete. All right, so our next cycle. When in danger, bombardier beetles fire a hot toxic mixture of chemicals at their attacker. Kind of cool. Not kind of, that is cool. The mixture contains quinone, a really important thing for the British Empire and how they took over the world. A compound, C6H4O2. This is a compound that is formed by the reaction of hydroquinone and C6H4 hydroxides, two of them, with hydrogen peroxide. The equation for the overall reaction is C6H4OH2 plus hydrogen peroxide aqueous goes to quinone plus 2 waters as a liquid. Now we've got a tricky step here, and this is our target equation, right? We're happy with that. And we're going to do this in the cycles. So first off, you'll notice that we can get largely down, here we've got some sort of the elements involved. Here we have a different reaction involving these. Plus then we've got the steam here. So let's have a look at how we're going to set this up. We also need to watch out for this coefficient. Anywhere that we need to include water, so this is not something that gets cancelled out, right? Like this is part of our deal. Anywhere that needs to include this water, well, it's water at this point, steam down here, has to be doubled. That's important, which means the numbers here are going to double as well. So, write down our target equation, all right? Then we're going to put down this equation. So here's all of our components that exist in all of these, except for this one. This one's rude. And we'll sit there and draw how these work. First off, we need to also put our water as gas in the middle, right? So we can tell that we can go from this via that. We need to put that step in the middle. So you got to plan these out a bit. So we've labeled our blue, green, pink, and yellow. And that's just to show you where each line's going to go as we do this. All right, first off, blue. We come down here. This is plus 1774 as we write it down. Bang, going this way. Remember, this is pathway A, this is pathway B. All right, so we've got that. Goes down here to produce this plus hydrogen. Sweet. Then it goes up to there. So that's all still there, right? Like that's showing you that this is up to there. It doesn't have any enthalpy change because it's staying exactly the same, but we've drawn it down the bottom there. Alrighty. Here we have hydrogen plus oxygen goes up to produce our hydrogen peroxide. Okay, nice and straightforward there. Then we have our hydrogen and oxygen going up to produce steam, which then goes up to produce water. Now, again, you notice there's a 2 here, and there's one there, and one there. So we had to double these values. So it becomes 2 to minus 241.8, and 2 times minus 43.8. All right, off we go. Now, next step, bang. We're going over this way, down this way. We're summing these up to give us the same as that. Okay, so let's just put them straight in. Plus 174. This is going the wrong way against our cycle because it's on the left-hand side. So it's going against our cycle, so we have to flip the sign up here. And then we are multiplying this by 2, adding that. Multiplying this by 2, adding it there. Popping them all together, we get minus 202.6 kilojoules per mole. That was a slightly more complex one, right? Still same process. We had to add an extra step here, and we had to add some multipliers. Same process though. But that's how it's done. So it's starting to get it. And you see they start to build up in complexity as you go along. I hope that made a lot of sense. If you have any questions, any feedback, whatever, put them in the comments below and we'll get back to you as soon as we can. Thank you for watching. Hope to see you next time. Bye now.